Okay guys, you've done long division. Now for something a lot easier, synthetic division. When can you do that? Anytime you have a simple denominator that is just x plus a constant or x minus a constant, like these two examples. So let's try it. So when I am doing synthetic division, well, the answer really, if I was doing this, would be x equals -2. So that's what I'm going to divide by, -2. And I'm just going to write the coefficients underneath the house. 3, -1, +1, -2. I'm going to draw my line, and now I bring down the 3. 3 times -2 is -6. And now with synthetic, you add. So -7, this is 2 times -7 is +14. That's 15. 2 times -15 is -30, -32. So you're always just adding, so it's much simpler. Now, let's come back. We started with, this was really 3x to the third. What we're going to do is this number is the depressed or reduced polynomial. And we always just reduce it by 1 because we're just dividing by x. So this is now 3x squared. So that's now our answer. The answer to our division problem is 3x squared minus 7x plus 15, and then this is our remainder, and then our remainder is minus 32 over x plus 2. Okay, let's try one more. This time we're dividing by x is 1. And I'm going to write -3. Now remember, I got to put in 0, x cubed, 0, x squared, -2x, and -1. Bring down the -3. Then -3 times 1 is -3. Now add. -3 times 1 is -3. Add. -3 times 1, -3. Add is -5, -5 is -6. That's my remainder. So since this was x to the fourth, my depressed polynomial is then x to the third. My answer is -3x to the third minus 3x squared minus 3x minus 5 minus 6 over x minus 1. Okay, so now we're going to do the remainder theorem. The remainder theorem is a handy theorem that lets you use synthetic division to actually evaluate functions. Now, let's say I had f of 4. You guys know how to evaluate this. It would be 2 times 4 to the third minus 4 times 4 squared plus 3 times 4 minus 5. Now, that's not so bad if you have a calculator, which I have, and that's 71. But what if I didn't have a calculator? Is there another way of doing this? Yeah, I can use the remainder theorem. So let's see what this is. Okay, so I'm going to divide by 4. And now I'm going to write down all my coefficients: 2, -4, 3, -5. Do my synthetic division, bring down the 2. 2 times 4 is 8. Add, that's 4. 4 times 4 is 16. Add, that's 19. And then 19 times 4. 9 times 4 is 36. That's 76. 76 minus 5. Add, I get 71. Wow, same thing, right? The remainder, when you divide, is equal to what you get when you evaluate. Now, what this is saying is very handy. If you get a remainder of 0, then if you get a 0, f of c is equal to 0, then you know that x minus c must be a factor. This is mainly what we're going to be using. Now, so this time they're saying 1 is a 0. So that would be the same as 1 is a 0, x is 1, right? So it says solve this equation. Well, that's going to be kind of hard. I can see I can't automatically factor it. I can't use grouping. So given the fact that I do know that 1 is a factor, it's a 0, I can just do synthetic division to reduce the polynomial. So I'll bring down 2, -1, 2, -3. Do my synthetic division. 2, 1 times 2 is 2. I add, I get 1. 1 times 1 is 1. Add, you get 3. 3 times 1 is positive 3. Add, and I get 0. That's what I expected, right? They said 1 is a 0, so the remainder should be 0. Now, here's the handy thing. This is x to the third. This is now x squared. So now I have a polynomial, which is simply a quadratic. And now I can solve this by just using the quadratic formula. So x equals -1 plus or minus the square root of 1 squared minus 4 times 2 times 3 all over 2 times 2. So x is -1 plus or minus, that's 8 times 3, that's 24. So 1 minus 24 is -23 over 4. Or we would write it as -1 plus or minus root 23i over 4. Notice the I is on the outside. When you actually write it with an I, it should not be under the square root, because I means the square root of -1. You already have the square root by writing the I. Okay, so now we found our 3 roots. This is x to the third. So we have x is 1 and we have these 2 roots.